everyone. Today I will be talking about Beacon, which is a high-performance data lake and processing platform designed for access and subsetting large quantities of climate data. A bit about the history of Beacon. So in the case of CDataNet, we had already for a long time large collections of observation data that contain millions of files. And in this case, access to the files, the data sets is possible, but the data subsetting, so slicing through the data in time, region, depth, proved to be difficult. So we were looking for a tool or system that could help optimize for access to subsets, enabling actually easy access to these large collections in Jupyter Notebooks. So how do we go from serving files to actually serving a data lake? An example request could be, I want to get or obtain all the temperature data in the North Sea for a period of 10 years in degrees Celsius for a depth between 0 and 5 meters. And I just want to return one single netcdf file, which I can directly on the fly use in my notebook. What is Beacon? So it's written in Rust and C. It's a high-performance data lake. It runs on Linux, Windows, and consists of Docker containers, a REST API, core libraries, and allows for real-time subsetting. Provides data harmonization, so it gives one single output file that you can choose the format of. It does dynamic chunking in geospatial chunks or chunks on time. That's up to the provider to decide. And as I said before, it can produce different output formats. It also can handle any type of netcdf structure and allows for powerful query possibilities. So it's currently freely available on the beacon.mars.nl. There's some documentation page on it available. There's also a GitHub that you can access. And looking at Beacon, it's from the provider point of view, you're able to set up your own Beacon node, allowing others to get easier access to your data. Or you can use one of the Blue Cloud 2026 marine nodes, so the large data collections in the marine domain that we've made available also with example notebooks. And here are some of the nodes that we have available. So we have EuroArgo, Coroa, the EMODnet chemistry collection, the World Ocean Database, CDataNet CDI, and the Copernicus Marine BGC collection. It's possible to create Beacon from a notebook, clearly indicating what kind of columns and filters you want to apply. And you can then search through the Beacon node and obtain on the fly in your notebook the collection that you're looking for. So I will now shortly demonstrate that in a Jupyter notebook environment. So now we're looking at one of the example notebooks that we have for Beacon. We're looking here at the World Ocean Database, which is one of the marine data infrastructures that we have a Beacon node available for. So first thing first, you need to have a token. This token you can access and obtain via the Blue Cloud 2026. And there's also explanation how to obtain this token on the documentation page of Beacon. So you need to have the URL of the instance. In this case, it's beacon-wod.mars.nl. And then here what we see is we try to get all the columns that we can query for this specific World Ocean Database node. I just display here the first 10 parameters, but basically this means that these are the columns that you will be able to retrieve from this specific node, and also the columns that you will be able to filter on. Then the next step will be to set up this query body to send to the Beacon endpoint. So here you identify and specify what columns you want to retrieve and also what filters you want to apply. So here we see that we include the column time and we give it an alias. So that's the output column name that we give to our data frame. We want temperature, we want the standard name of temperature, we want the units, we want the depth, the longitude, latitude. We also want the dataset column, so the type of platform. And then we here specify our filters. So we say, okay, the top 5 meters of the ocean. We do a certain time period. So we select all measurements globally between the 1st of January 2010 and the 31st of December 2010. And also we specify here a temperature filter from -5 to 40 degrees Celsius. But of course, all these filters are optional, and you can choose which columns you want to retrieve. We specify an output format, in this case packet, and then we send here to the beacon endpoint, we send our post request. So then it starts running, and it eventually gives us here this data frame with 1 million rows for this year of 2010, with measurements from the World Ocean Database. And we see here that we get temperature, we get there indeed the columns that we requested for the filters that we applied. And then in this example, we can also do some visualization in Python, so we can look at the features on the map. In this case, we zoom in and we see some information on the properties, so the data. We can look at weekly temperature plots, for example, which is also interesting to do. But it just shows you that on the fly you're easily able to go through these collections and just create plots really quickly. So we end here with the daily global mean seawater temperature that we obtain from this large collection. And this, of course, is also all possible with other data collections that we have included in Blue Cloud. So feel free to test them out. Thanks.